Now we're ready to sub in A0, AN and BN into the overarching or the mothership formula, right, from Fourier series in the back of the exam paper. And this is the big formula. Now remember, our period is 2 pi as well. T equals 2 pi. So we can sub in a few bits here first. We're going to have pi over 2 there, because that's A0, plus the sum from n equals 1 to infinity. We're going to keep AN here now for a second, right? We're going to tidy these guys up in a similar fashion. So 2n pi t over 2 pi here, plus bn sine 2n pi baby t over 2 pi. So you can see where this is going from earlier. Pi over 2 divided by 2 is pi over 4. Plus, we're going to have an times cos, the 2 pi's disappear above and below there, and we have nt plus bn sine, and again the 2 pi's cancel above and below, and we have bn sine nt, like so. Now I need a bracket here. So now I'm just going to examine the an cos nt bit here, right, from n equals 1 to infinity. So an, what's an again? An equals 1 over n squared pi multiplied by 1 over n squared pi multiplied by minus 2 when n is odd, and multiplied by 0 when n is even. So the whole thing is going to go to 0 when n is even. And cos nt, that's okay. So let's go when n equals 1, what's going to happen? Well, it's odd. So when n equals 1, we're going to have 1 over 1 squared pi multiplied by minus 2. And that'll give us minus 2 over 1 squared pi times cos nt. So you'll have cos of 1t, and we won't bother with the 1 then, so we have cos of t. Right? Now when n equals 2, this is going to be 0 here, so you're going to have 0 multiplied by 1 over n squared pi, and it doesn't matter what you write down here because it's all going to go to 0, cos 2 pi, so that's going to 0, right? The whole thing here goes to 0, and when n equals 3, we're going to have minus 2, because n is odd now, we're going to have minus 2 over 3 squared pi times cos of nt. So n is 3 now, so you have cos of 3t. When n is 4, it's going to 0. When n is 5, we're going to have minus 2 over 5 squared pi times the cos of 5t, let's squeeze it in there, right? So just examining, if we just look at the sum from n equals 1 to infinity of an cos nt, we can write it like this. It's going to be equal to minus 2 over 1 squared pi times cos t, and the next bit then, so the next bit is going to be minus 2 over 3 squared pi cos 3t minus 2 over 5 squared pi cos 5t, and so on, minus 2 over 7 squared pi cos 7t. So that keeps going like that. So we're going to summarize that with the notation here. So the first thing we can do is we can pull out, what can we pull out? We can pull out the minus 2 over pi. And what happens then? Then you're left with, what are we left with? Yeah, we're left with cos t and plus cos 3t, and we're left with the 3 squared there over the 3 squared. You could say that that's over 1 squared if you want the pattern to look good. So if cos 5t over 5 squared, etc., and onwards to infinity and beyond, maybe, right? So that's what's going on there. Now, we have another couple of tricks we can do then. You see, we've 1 here, 3, 1, 3, 5, 7, and 1 squared underneath. So we can write it like this. We can put in cos of 2n minus 1t over 2n minus 1 squared. And how do I know that works? Well, if you test it out, when n is 1, 2 times 1 is 2, minus 1 gives you 1 there, and down here is 1 as well. Now say when n equals 3, 1, 2, 3, this is when n equals 3. Well, look, 2 times 3 is 6, minus 1 is 5, so it works there as well, right? So we can say that, what can we say? That this thing here, the sum from n equals 1 to infinity of minus 2 over pi times cos 2n minus 1 t over 2n minus 1 squared, that's equal to our first bit up here. You see this bit here? That's equal to that bit there, right? And then we're going to separately examine the bn sin nt bit now in a second. Now, so that's the an causes nt bit. Now we're going to look at the bn sin nt bit, right? So bn, remember we had bn, we got this for bn, minus 1 to the power of n plus 1 over n. Right, and just looking at that little bit there, you know, sum from n equals 1 to infinity of bn multiplied by sin nt. Like when n is 1, then, you know, you're going to have minus 1 to the power of 1 plus 1 over 1. Sin n is 1, so sin 1t. And when n is 2, we're going to have minus 1 to the power of n is 2, so you have 2 plus 1 over 2 sin 2t, and so on. And then the next one will be as n is 3, so you have 3 plus 1 up here, and then you have the 3 down there as n sin 3t, you know, and so on. Next one then, n is 1, 2, 3, 4, so we have 4 here, 4 plus 1 sin 4t, and that goes on, right? So how are we going to summarize that? Well, you see the pattern, you can see a pattern there. You're going to have minus 1, and then you have n here for 1, 2, 3, and 4, so you can have n plus 1. Yeah, I think that's it. And you have n below, and then we have sin nt here. You know, so that bit's going to slot in. That bit is equal there, you know, right? So going back to the original formula there, so if we go back up as far as here, right, I'm ready to slot in. We were ready to slot in our summary of our sum of the an bit there. This guy can slot in at the start. That's going to slot in here. And the bn sin nt, this bit fella will slot in up here, right? So, well, actually down there, right, at the star there, at the star. So I can copy that down actually, right? So there it is there. Load up a wee bit, and I'm going to rewrite that now. Let's get the pen sorted out here. We still have our pi over 4, and it's going to be plus n equals 1 to infinity of these two structures. And the second structure there is going to be plus minus 1 to the power of n plus 1 over n, because just I have it here handy, sin nt. And the first structure then was this messy looking stuff here. Minus 2 over pi, open a bracket, and then we had cos 2n minus 1 t all over 2n minus 1 squared. And then to make that exactly look like what was suggested in the question, with pi over 4 plus, we can apply this fella here to this, right? So we get the sum n equals 1 to infinity of, we could have just left them separate actually, instead of what I was doing, joining them together, cos 2n minus 1 t over 2n minus 1 squared, right? Plus, I should have left them separate. And in the question, they shuffle these around. This is multiplied, so we can have the sine nt first. The order isn't important, right? And we can shuffle the n under there, slide the n under that, and then the whole thing is multiplied by minus 1 to the power of n plus 1. That just controls the sign, the polarity, the minus or the plus 1 aspect of it. Don't really need that. I'm going to get rid of this little bracket here, right? And then finally the minus 2 over pi comes out in front. So I'm going to copy that. Or am I? No, I'm just going to take out I'm going to erase. I can erase that minus 2 over pi. And I can stick it out in front of the sigma here. So you get, well, it's going to get messy now. I can erase the plus then as well. And I get pi over 4 minus 2 over pi times sigma times this guy here. The sigma applies to this structure here, plus a separate sigma then n equals 1 to infinity of this structure here. And that's it done. It ain't easy, and there's, but there's a lot of tips and tricks in there. And even if you got your A and B in, A0, AN and BN sorted, you'll be scoring a lot of marks. So don't be losing heart. Keep practicing.